Hello, and welcome to Train Signal. I'm Don Jones, and this is the Indexes lesson in the Database Administration Fundamentals course. In this lesson, you'll learn the basics of database indexes. We'll talk about clustered indexes, non-clustered indexes, index page splits, and index maintenance concepts. As you've already learned, indexes can make it faster for SQL Server to look up data and to sort data by giving the server with a ready-made cross-reference. SQL Server uses two types of indexes. You can have one and only one clustered index on a table. You can have as many non-clustered indexes as you need. Before we talk about the difference between clustered and non-clustered indexes, let's briefly talk about how they work. SQL Server indexes are in a structure called a B tree or binary tree. The point of a B tree is to let SQL Server make a series of yes/no decisions for each phase of a search. For example, suppose that we needed to look up a customer named Jones. The B tree essentially divides all of the possible data into two chunks. Each chunk is then subdivided into two chunks, which is subdivided into two chunks, and so forth. So we would start at the top of the index. Well, we know that J, or Jones, is somewhere between A and Z, but is it between A and M or between N and Z? So that's a binary decision, one or the other. It's obviously between A and M, so we go down to the next level of the tree. We see that it is divided into A through G and H through M. So we'll choose the H through M path. From there, we see that it's divided into H through J, or K through M. Obviously, it would be in the H through J part, and so we continue to traverse the tree, going down to ever smaller chunks until we finally find the row that we're looking for. We would find that in the H through J section. A clustered index physically determines the order in which data lives inside the table. So if you were to build a clustered index on a customer name column, the data would be physically reordered into that alphabetical order. Clustered indexes provide the fastest lookups because they affect the data storage. So you typically put your only clustered index, because remember, you can only have one, on the most commonly used column. And even if you don't create a clustered index, all tables have a clustered index. If you don't make one explicitly, SQL Server will just use the arbitrary row ID, which essentially is the order in which the rows were added to the table. This type of table is called a heap. A non-clustered index is a separate structure containing only the key values in whatever order you specified, along with a pointer to the associated database rows. This is more like a traditional index, like the kind you'd find at the end of a book. Let's go into SQL Server Management Studio and create some indexes. I'll continue working in my test database for this example. Let's go into the design of the orders table. And because I'm going to use this ID column to frequently look up orders, it makes sense to create that as my clustered index. I'll right-click and select Indexes. And as you can see, I already have an index. It's the one that was automatically created when I designated the ID column as my table's primary key. And you can see that this was created as a clustered index. That's a little trick that a lot of people don't realize initially. When you designate a column as the primary key, SQL Server knows that you're going to be using that value to look up rows pretty frequently, and so it automatically creates that as your clustered index. Because most well-designed tables will have a primary key, most tables will therefore have a clustered index. I might also frequently need to sort orders by the date they were placed, or even look up all the orders placed on a certain date. I think I'm going to do that frequently enough that it will make sense to have an index on the order date. So we'll go back to Indexes, create a new index. This one will be called IX Orders. I'm going to create it on the order date column in ascending order. It is not going to be unique. It is not created as clustered. You'll see that because I already have a clustered index, this is actually grayed out. I can't change it. And I don't necessarily need it to change any of these other things in here. So we'll just close that, and we can then save the table to make that change take effect. If we go into any other table, now we'll switch back over to the AdventureWorks table, or database. Let's grab something out, like Department from Human Resources, and take a look at its indexes. This has its primary key, its clustered index, built on the Department ID column. Again, that happens automatically. Can't change it once you've made something the primary key. But there's also another key, and let's see what this one is. This is a unique non-clustered index, and it is on the name. So whoever's using this anticipates having to frequently sort or filter on the name of the department, and so they've created an index to speed up that operation. And that's what indexes are really for, speeding up the retrieval of data, speeding up the sorting of data, and speeding up the filtering of data, all as you're retrieving. Just like the actual data in a database, indexes are stored on 8 kilobyte pages. As data is added to the table, these index pages can fill up. When SQL Server needs to add more data to an already full page, it has to split that page. That frees up room on that page for new entries, but it does result in the index pages being fragmented or out of order. For example, let's say this represents our index. The data is currently stored on 3 pages, the first 2 of which have been filled up. We need to add an entry for the letter D. It would normally go on the first page, but the first page is full. So SQL Server will split that page. At the end of the index structure, it will create a new blank page. It will move some of the data off of the first page onto this new blank page, freeing up room for our new value to be inserted. So our index is taken care of now, but it's now out of order. As SQL Server reads through this and tries to traverse that B tree, it has to jump from the first page all the way to the 4th page, then back to the 2nd, and then finally to the 3rd. That out-of-order reading will eventually create enough of a performance impact that the index itself becomes less useful. In other words, imagine if you had an index at the back of the book, and rather than being able to read through it alphabetically, page 1, 2, 3, and 4, you had to flip from page 1 to page 10 to page 3 to page 8 to page 6. Eventually, that flipping back and forth is going to use so much time that it will negate the time savings that the index was supposed to create. If an index gets badly fragmented enough, SQL Server will actually stop using it, and it will switch over to a table scan when it needs to find data. Those table scans are much less efficient, but that just tells you how bad a shape your index is actually in. That's why index maintenance is so important. Periodically, you will need to maintain your indexes. There's really 2 things you can do. Rebuilding means constructing the entire index over again, and you can specify how much empty room to leave. That's called the fill factor, to accommodate future growth. Reorganizing means rearranging the existing index. It's faster than rebuilding, but it doesn't reclaim freed up space as well, meaning there's still a little bit more waste. In the newest versions of SQL Server, both of these operations can be performed while the database is up and being used by other users, although there's obviously a performance hit of some kind because you're doing all of this extra work in the background. The fill factor is something to kind of keep in mind. It's an important planning decision. A very low fill factor means you'll have plenty of free space on your index pages for new data, meaning you're less likely to get index splits. However, it means that each page contains less data, so in order to read through the index, SQL Server has to read more pages, which takes longer. So the fill factor, like many things in SQL Server performance, is a matter of balance, finding the right balance for your particular database. Let's go back into SQL Server Management Studio and take a look at some of these index maintenance tasks. Let's continue working with the Human Resources.Department table in the AdventureWorks database. Now, I showed you how to look at its indexes in table design mode, but you can also expand the table to get to the indexes individually. You can see here that my primary key has a slightly different icon on it because that's a clustered index. Let's right-click the non-clustered index, select Properties. This is a unique non-clustered index. We can see that. On the options, we can set a fill factor. Let's say that we anticipate very few changes being made to this database. So we don't anticipate a lot of page splits. So we'll set the fill factor to 100%. That means when we rebuild the index next time, each index page will be completely full with no room left over for additions. That's okay. I don't add a lot of departments to my company all that often, so I don't anticipate that being a big deal. By keeping each page full of data, I can help SQL Server read through the index faster because each page that it reads will include more data. I'll click OK. Simple maintenance can be done by right-clicking and selecting either Rebuild or Reorganize. I'll select Rebuild, and that's automatically happening. I just need to give it the approval to proceed. Let's see, everything looks okay. Yep, let's go. And it was that fast. It's not a huge table, so the index was able to be rebuilt very, very quickly. You do need to get into the habit of periodically reorganizing or rebuilding your indexes over time. That's especially true with tables that have a lot of new data being added all the time. No matter how small of a fill factor you initially specify for the index, eventually those pages will fill up and the index will start to become fragmented. You can check that. Let's go down to person.address here. Look at the indexes. You've got several here, so let's just pull up one. Properties. One of the tabs here is fragmentation. So this is quickly analyzing the index to see how fragmented it actually is. We'll see what it comes up with. This is telling me that each page is about 99.5% full, and there is currently no fragmentation. So it's likely that my database administrator recently rebuilt or reorganized this, so there is no fragmentation. This is an easy way to check on that so you can determine if the index needs to be reorganized or rebuilt sometime soon. In this lesson, you learned the fundamental concepts of SQL Server indexes. We talked about clustered indexes and non-clustered indexes. You learned about index page splits, and you learned how to perform maintenance on indexes.